Hi students, good morning to all of you. Hope you are all doing well. Welcome to fifth lecture in quadratic expressions. Hope you have reviewed all the previous four lectures in order to follow this lecture. In this lecture, we are going to discuss some problems based on three theorems regarding sign of change of quadratic expressions. Okay, let us discuss some problems related to the above theorem. Okay, the problem goes like this. For what values of x, the expression 15 plus 4x minus 3x square is negative. So we have to solve this question with the help of the above three theorems. Okay, the solution goes like this. See, in doing these kind of problems, the first step is find out delta value. Find delta value. Okay. Okay. After finding out this delta value, if delta is less than 0, apply theorem 1. Okay. If delta is equal to 0, apply theorem 2. And if delta is greater than 0, apply theorem 3. So this is a practice in answering these kind of questions. Okay. Now here in the current problem, A is minus 3 and B is 4 and C here is 15. Let us find out this quantity delta, that is B square minus 4AC. What is B square minus 4AC here? 4 square minus 4 into A is minus 3 and C here is 15, that is 16 plus 15 into 4 is 60, 60 into 3 is 180. So this value is 196. This is positive. So discriminant is positive. That means we have to apply theorem 3 actually. Okay. That means here in this case you have to find out the roots also. Okay. The roots of the equation, the expression are, the roots of the equation are alpha comma beta is equal to minus b plus or minus under root b square minus 4ac divided by 2a. So this is minus b is minus 4 plus or minus under root b square minus 4ac is 196 divided by 2 into minus 3. So the roots are minus 4 plus or minus 14 divided by minus 6 actually. So this is minus 18 by minus 6 comma minus 10 by 6. So the roots are 3 comma minus 5 by 3. Okay. Now let me draw a real number line here. So alpha is equal to minus 5 by 3 and my beta is equal to 3 here. This is my beta and this is my alpha here. Okay. Now let f of x is equal to 15 plus 4x minus 3x square. Okay. And a value here is minus 3, which is negative. Okay. So a value is negative. So this f of x in this region, it takes positive sign, and f of x in this region takes the same sign. That is f of x is less than 0. So these are the things that we require actually. Okay, so what is the conclusion? The conclusion is, okay, so in this region and in this region, the expression is negative. So this 15 plus 4x minus 3x square will be negative if x belongs to the region minus infinity to minus 5 by 3 union 3 to infinity. So this is the conclusion. And if at all a question is asked like this, when is this expression positive? When is this expression positive? We can write if x belongs to the interval minus 5 by 3 to 3. If at all a question is asked like this, when does this expression is positive? Okay. Hope you have understood the solution for this question. Okay. Let us solve one more question. The question is, for what values of x the expression 4x minus 5x square plus 2 is positive? Okay. Let us find out the solution for this. Here is the solution. The solution goes like this. Okay. Let us write down what is A. A is minus 5 and B here is 4 and my C here is 2. Okay. Now what is delta here? B square minus 4 into AC. B square minus 4AC is B is 4 square minus 4 into A is minus 5 and the C here is 2. So this is going to be 16, 5 into 2, 10, this is 50, this is 40. So what is delta value that you have got is 56. So we have to apply theorem 3. Okay. Now we have to find out the roots. We have to find out the roots here. So the roots are given by the formula. It is minus b plus or minus under root b square minus 4ac divided by 2a. So that is minus 4 plus or minus under root 56 divided by 2 into a is minus 5. Okay. So the roots are so this can be written as minus 4 plus or minus, this can be written as 14 into 4, that is 2 into root 14 divided by minus 10. So if I simplify it, what do I get is minus 4 minus 2 root 14 by minus 10 minus 4 plus 2 root 14 divided by minus 10. So those values are 2 plus root 14 divided by 5. This is one value, and the other value is 2 minus root 14 divided by 5. Okay. So here alpha is equal to 2 minus root 14 divided by 5 and beta is equal to 2 plus root 14 divided by 5. in this case we have to draw the diagram as alpha comma beta, and a is positive here, sorry, a is minus 5, which is negative. If this is negative, so what is the conclusion here? So in this region, this f of x is going to be, if it is negative, and this is going to be positive, and in this region takes the same sign, it is negative, and f of x is negative here. Okay, now what is the conclusion here? Okay, the conclusion is 4x minus 5x square plus 2 is positive if, where is it positive, where if x belongs to 2 minus root 14 divided by 5 to 2 plus root 14 divided by 5. If the question is asked for what values of x the expression is negative, we have to write the answer minus infinity to 2 minus root 14 divided by 5 union 2 plus root 14 by 5 to infinity. So in the question they have asked this particular thing, when is the expression positive? So since a is negative, the expression will take the positive sign. Okay, hope you have understood the answer for this. Let us solve the next question. Here is our next question. So for what values of x the expression 3x square plus 4x plus 4 is positive? Okay, the solution is here. Let us write what are ABC values. A is equal to 3, B is equal to 4, and C is also equal to 4. And what is discriminant? B square minus 4 into AC. B square is 4 square minus 4 into A value is 3 and C value is 14, that is 16 minus 16 into 3 is 48. So delta is equal to minus 32, which is negative value. This implies the roots of the given expression are negative. Sorry, these are not negative. Roots are complex. Roots are complex. So if the roots are complex, then we have the conclusion from theorem 1. Apply theorem 1. So what does this theorem says? Okay. So here in this problem, a is equal to 3, which is positive. So the conclusion says like this: the expression and a takes the same sign. Since a is positive, okay, here let f of x, I'll assume it as 3x square plus 4x plus 4. Since a is positive, then according to by theorem 1, f of x is also positive for all x belongs to real. So what is the conclusion? The conclusion here is 3x square plus 4x plus 4 is positive for all x belongs to R. Suppose a question is asked like this. For what values of x this expression is negative? The answer is what is the answer in this case? The answer is null set. That means no real number will satisfy that inequation. No real number inequation. This inequation I am talking. 3x square plus 4x plus 4. This cannot be negative for any real number. Okay, hope you have understood the answer for this question. Let us solve one more problem. So find the range of this expression. So here in this question, okay, they have asked us to find the range of the expression. So what is it? Find the range of this expression. So they are talking something about the range of this expression. So actually a range in terms of a function. Okay, now if I take this as function, okay, function will have some domain and range. Okay, so in that aspect, considering this as a function, they are asking us to find out the range actually. Okay, now let y be an element of range of f of x is equal to the given expression 2x square minus 6x plus 5 divided by x square minus 3x plus 2. Okay, now how do you find out the range? Actually we'll equate that f of x is equal to y and then find out the value of x actually. Now let me do the same method, same way. Okay, let y is equal to this 2x square minus 6x plus 5 divided by x square minus 3x plus 2 implies upon rearranging the terms, what do I get is y into x square minus 3x plus 2. I am writing as it is 2x square minus 6x plus 5. So this implies if I rearrange the terms, what am I going to get? Let me write it here. X square into y minus 2. So x into minus 3y plus 6 plus 2y minus 5 is equal to 0. That means in order to find the codomain, in order to find an element, okay, because usually this is how here x values will be there, here f of x value will be there, here you have taken y, you have to find out the pre-image. Okay, now to order to find out the pre-image, what you will do is y is equal to f of x and in turn you will find out this x. This is what we are doing here. Okay, this expression that means you have to solve a quadratic equation. That means you have to solve a quadratic equation. But one information we know about this function is the domain of this function is going to be reals. Okay, the domain of this function is going to be real. That means the roots of this quadratic equation are real. Okay, when does the roots of this equation real? Okay, we know that equation 1 has real roots. Why? Because we are actually finding the pre-image. That's why. So this implies, when does the equation 1 has real roots? This happens if and only if discriminant is greater than or equal to 0. So what is the discriminant here? The discriminant is minus 3y plus 6 whole square minus 4 into y minus 2 into 2y minus 5 must be greater than or equal to 0. Okay, let us simplify this. So this is 9y square plus 36 minus 2 into 3 6 into 6 is 36. This is 36y. Okay, this is equal, this is minus 4 into y into 2y, that is 2y square minus 5y minus 4y plus 10 must be greater than or equal to 0, implies. Okay, 9y square minus 8y square, this is going to be y square. This is minus 36y, and here also I get plus 36 and minus 36. So it is plus 0 into y. Now I am left with the constant terms, 36 minus 40. So it is minus 4 must be greater than or equal to 0. That means we have arrived at the equation y square minus 4 greater than or equal to 0. From here onwards, we get into the previous problems. Okay. Now this y square minus 4, this can be written as y minus 2 into y plus 2 greater than or equal to 0. Here alpha is equal to minus 2 and beta is equal to 2. Okay, so when is this expression positive? Okay, let me draw a real line here, minus 2 comma 2, and the a here is anyway positive. Here a is positive. Okay, this expression must be positive in this region. This must be positive. Okay, so this implies the conclusion is we have to apply here. You have to apply theorem 3 as it has real roots. Okay, now the conclusion is y minus 2 into y plus 2 is greater than or equal to 0 if and only if y belongs to the interval minus infinity to minus 2 union 2 to infinity. So the range of the given expression is minus infinity to minus 2 union 2 to infinity. So here is the solution. Let me discuss a problem on change of sign of quadratic expressions. Here is the problem. For what values of x the expression x plus 1 into x minus 3 by x minus 2 is positive? Let us find out the solution for this. solution. I'll write it here. Okay. Now what I'll do is let f of x is equal to x plus 1 into x minus 3 divided by x minus 2. Okay. Now we have to find x belongs to reals such that f of x is positive. Okay. Now what I'll do is I'll do a small modification for this expression. X plus 1 into x minus 3 divided by x minus 2. This I am writing as it is, x plus 1 into x minus 3 divided by x minus 2. So what I'll do is I'll multiply and divide both numerator and denominator by x minus 2. So this becomes x plus 1 into x minus 2 into x minus 3 divided by x minus 2 whole square. Now let me write it as h of x divided by g of x. Okay, so this is nothing but my f of x. Okay, so what is my f of x? F of x is equal to h of x divided by g of x, and g of x is positive. Okay, because it is x minus 2 whole square. So for f of x to be positive, then h of x must be positive. H of x must be positive. Now the question is, so it is equivalent to say that f of x is positive if and only if x plus 1 into x minus 3 into x minus 2 is equal to h of x. This must be positive. Now let us find out for what values of x h of x is positive. Here we are going to apply a technique that we have discussed in proving theorem 3 actually. Okay, so the same technique I am going to discuss here. So you draw a real number line, okay, indicating the roots of this equation. Okay, x plus 1 into x minus 3 into x minus 2 is equal to 0, let us say. So x plus 1 is equal to 0 means it becomes minus 1, and here it is 2, and here it is 3. On the real number line, this is what is the order actually. Now this entire real number line is divided into 4 regions. R2, here it is R3, and here it is R4. Okay, now so region 1. In region 1, what happens? Let us see. That is, if x belongs to region 1, that is what? X is less than minus 1, less than 2, less than 3. So this implies x plus 1 is less than 0, x minus 2 is less than 0, x minus 3 is less than 0, implies x plus 1 into x minus 2 into x minus 3. See, it is negative quantity, negative quantity, negative into negative into negative, this becomes negative. Okay, so in region 1, that is x less than minus 1, this h of x is that is h of x is negative. Okay, let us continue this problem. The problem is continued here. Problem continued here. So let me draw the real number line here also. So here you have -1, here you have 2, and here you have 3. So this is region 1, this is region 2, this is region 3, and this is region 4. Now, if x belongs to region 2, that is, x lies between -1 and 2. So that is, then this becomes less than 3 also. Okay, so this implies x plus 1 is greater than 0, x minus 2 is less than 0, and x minus 3 is also less than 0. So this is positive quantity, these two are negative quantity. So this implies x plus 1 into x minus 2 into x minus 3 is positive. So this implies h of x is positive if x belongs to the interval -1 to 2. Okay, next, if x belongs to region 3, that is -1 less than 2 less than x less than 3, that means x is here. This implies x plus 1 will be positive and x minus 2 will be positive and x minus 3 will be negative, implies positive quantity into positive quantity into negative quantity. This implies x plus 1 into x minus 2 into x minus 3 becomes negative. Okay, now if x belongs to region 4, that is -1 less than 2 less than 3 less than x, this implies x plus 1 is positive and x minus 2 is also positive and x minus 3 is also positive, implies x plus 1 into x minus 2 into x minus 3 will be positive. This is your h of x. Okay, so this implies h of x is positive if x is greater than 3, that is x belongs to the interval 3 to infinity. So if you observe it, let me mark those regions. So in this region and in this region, okay, I think in this region, right? So okay, so the final conclusion is h of x is positive if x belongs to -1 to 2 union 3 to infinity. So this is the actual solution set for the given equation, given inequation actually. Okay, so this is how one can tell the expression is positive or negative. And you can observe one more thing here. See, if I write the sign here, in this region, the expression is negative. In this region, it is going to be positive. In this region, it is going to be negative. And in this region, it is going to be positive. So alternatively, it becomes negative, positive, negative, and positive. So remember this technique. So even if we are given with 4 factors also, we'll be able to answer by using this technique. Okay, hope you have understood this problem. Okay, let us continue with one more problem. Let us solve this problem. The problem here is, if x is real, prove that this function lies between -1 by 11 and 1. This is actually a range type of problem which we have solved earlier. Let us find out the solution for this. Solution here. Okay, and like in the previous problem, let f of x is equal to y is equal to x divided by x square minus 5x plus 9. Okay, where y be an element of range of f of x actually, right? Okay, if you rewrite this expression, we get is y into x square minus 5x plus 9 is equal to x. If we rearrange the terms, I get y this is y into x square plus x into minus 5y minus 1 plus 9y is equal to 0. We call it equation 1. We know that roots of equation 1 are real, implies discriminant of 1 is greater than or equal to 0, that is discriminant is greater than or equal to 0. Now what is the discriminant? Delta is equal to minus 5y minus 1 whole square minus 4 into y into 9y, so that must be greater than or equal to 0. This must be greater than or equal to 0. So this is 25y square plus 10y plus 1 minus 36y square must be greater than or equal to 0. So this is minus 11y square plus 10y plus 1 must be greater than or equal to 0. This implies 11y square minus 10y minus 1 must be less than or equal to 0. Okay, let g of y is equal to 11y square minus 10y minus 1, let us say. Okay, the roots, if you consider, okay, let me write 11y square minus 11y plus y minus 1 is less than or equal to 0, implies 11y, if I take common, this becomes y minus 1 plus y minus 1 is less than or equal to 0, implies 11y plus 1 into y minus 1 is less than or equal to 0. Okay, that means the roots of the above inequation is minus 1 by 11 and this is 1. So here for the above expression a is equal to 11 which is positive, then g of y must be negative in this region and g of y is positive in this region. So we want this inequation, we want solution for this inequation. So this implies 11y square minus 10y minus 1 less than or equal to 0 if and only if y belongs to minus 1 by 11 to 1. Here is the final solution. This is the solution. Let us solve one more problem. The problem is if the expression x minus p by x square minus 3x plus 2 takes all real values for x belongs to R, then find the bounds for p actually. Let us get into the solution. First of all, let us try to understand what is given. Okay, now let me take my f of x is equal to x minus p divided by x square minus 3x plus 2. If I consider this as a function, what they are giving is this f of x takes all real values. This f of x is going to take all real values for x belongs to R. That means if we treat this as a function, okay, this is the domain actually, this is the range. So the domain is entire reals, and what they are telling is this f of x. So from this set to this set, we are defining this function f of x, and the range is going to be R because the function is going to take all real values. This is what is given here. Okay, now let me take this as y, where y be an element of range of f of x. Okay, now let me rewrite this expression. Y is equal to x minus p divided by x square minus 3x plus 2 implies this is y into x square minus 3x plus 2 is equal to x minus p implies, so this is yx square plus x into minus 3y minus 1 plus 2y plus p is equal to 0. We call this as equation 1. Okay, as we did in the previous case, if we solve equation 1, we are going to get the pre-images, and the pre-images are real. Roots of 1 are real. Okay, this we know it actually. We know the roots are real actually. This implies delta of 1 must be greater than or equal to 0. This implies what is the discriminant of it? Minus 3y minus 1 whole square minus 4 into y into 2y plus p is greater than or equal to 0. So this implies this is 9y square plus 6y plus 1 minus 4 into 2y square plus p into y must be greater than or equal to 0. So this implies 9y square minus 8y square is y square plus 6y minus 4py. So it is y into 6 minus 4p plus 1 is greater than or equal to 0. And remember y be an element of the range actually. Remember y be an element of the range. Okay. Now what is the range of f of x actually? The range of f of x is R. That means this is true for all y belongs to reals. Okay. Now, so this expression is greater than or equal to 0 for all x belongs to, sorry, for all y belongs to R. So when does an expression is positive? This expression, if we consider this as an expression and it is positive, then by theorem 1 we have studied, then by theorem 1 the roots of y square plus 6 into, sorry, 6 minus 4p into y plus 1 is equal to 0 or complex in nature. This we have seen by, this is by theorem 1. So this implies when does the roots are complex, delta is less than 0. Implies the discriminant of this expression we are going to find out, b square minus 4ac, that is 6 minus 4p whole square minus 4 into 1 into 1 must be less than 0. So this implies 6 minus 4p whole square is 36 plus 16p square minus 2 into 4 8 into 6 48 minus 4 is less than 0. So this implies is 16p square. So this is 2 into 4 8, 8 into 6 48 p actually. So here I did a mistake. Let me rewrite this. So this is going to be 48p minus 4 is less than 0. So this is 16p square minus 48p plus 32 must be less than 0, implies throughout there is 16 common. So p square minus 3p plus 2 is less than 0, implies p minus 1 into p minus 2 is less than 0. So this happens if and only if p belongs to the interval 1 to 2 actually. Okay. So the bounds for p. So the bounds for p are, the bounds for p are 1 and 2 actually. So here is the solution. Okay, let us solve one more problem. Find the maximum value of the function x square plus 14x plus 9 divided by x square plus 2x plus 3 actually. Here I have to find the maximum value of this function. Let us see how are we going to do this problem. Okay. Right. Let us find out the solution for this. It is very similar to that of the range problem. Okay, let me take this as my f of x. Okay, let y be an element of a range of f of x. So then what I will do is y I am equating it to x square plus 14x plus 9 divided by x square plus 2x plus 3. X square plus 2x plus 3. Now upon rearranging the terms, x square plus 2x plus 3 into y is equal to, this is x square plus 14x plus 9. So okay, so here x square into y minus 1, x into 2y minus 14 plus 3y minus 9 is equal to 0. So we know that roots of equation 1 are real, because if we solve this equation we are going to get pre-image of y. So pre-image of y is always real. So this implies delta of 1 must be greater than or equal to 0. So that is 2y minus 14 whole square minus 4 into 3y minus 9 into y minus 1 is greater than or equal to 0. Okay, this implies upon simplifying, so let us simplify this. This is 4y square plus 196 minus 2 into 2 4 into 14 is 56y minus 4 into 3y into y, it is 3y square minus 3y minus 9y plus 9. This is greater than or equal to 0. So this upon further simplification, it is 4y square minus 12y square. So 4 minus 12, it is minus 8y square. So it is minus 56. So here it is minus 9, minus 3 minus 9, it is minus 12, minus of minus plus, it is 12 into 4 48. Okay, so minus 56 plus 48, minus 56 plus 48 is what? It is minus 8y. Okay, now we are left with the constant term. 4 into 9 is 36. So 196 minus 36, so it is 160 actually. So it is plus 160 is greater than or equal to 0. Now I multiply throughout with minus, I get 8y square plus 8y minus 160. Then the inequality is going to reverse. Now throughout divided by 8, we get y square plus y minus 20 is less than or equal to 0. Now this can be factorized. So it is y square plus 5y minus 4y minus 20 is less than or equal to 0. This implies, so y into y plus 5 minus 4 into y plus 5 less than or equal to 0 implies y plus 5 into y minus 4 less than or equal to 0. So the roots of this expression are, okay, I'm not getting the cursor here. Okay, okay, okay. Now the roots are minus 5 comma 4 actually. Okay, so on this real number line, let me draw a real number line. So I have minus 5 and 4, and this y square coefficient is positive. It is y square coefficient is equal to 1, which is positive. So here this f of x, sorry, g of x is going to be, this is going to be negative, and g of x will be positive in this region. Here g of x is this expression y square plus y minus 20. Okay, so this implies g of y is, what we need is, we need this less than or equal to 0. G of y is less than or equal to 0 if y belongs to the interval minus 5 to 4. Since it is less than or equal to, we have to write the closed interval here. So this implies the range, that is y belongs to this interval minus 5 to 4. That means the range set, this is actually the range of f of x. So the range itself is minus 5 to 4. So the maximum value, so the maximum value of the range is 4. So the given expression is going to, the maximum value of the f of x is 4 actually. This is the final answer. Okay.